So hello everyone, welcome back to the video, and in this video we are going to start with bit manipulations, and we will learn about what are bits and how we can apply bit operations to get some really cool outputs. So let's get started. Uh, we'll firstly see what are the topics which we are going to cover in this video. So the topics are first topics we are cover what are bits, then we are going to see some cool bit operations, then we are going to see some bit manipulations. Okay, it's very simple. Okay, so let's get started with the first one, that is bits. So what are bits? These are just bunch of zeros and ones, zeros and ones. Basically, this represent on, this represent off in a system. If you have studied a bit of binary system and decimal system, you will be already knowing it. If you don't, I'm going to briefly cover this here. So, like that in in general sense, we cover all the numbers in decimal form. What decimal means? It means 10. It means 10 power, 10 the power something. Right? That's decimal. And in decimal system, we have 10 digits that are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the 10 digits in decimal system. Apart from that, we have binary system. Apart from that, we have binary system, binary form. We have only 0 and 1 here. So in binary, the base is equals to 2, and in decimal, base is equal to 10. So in every system, digits start from 0 and goes to base minus 1. That is, let's say 10. So digits start from 0 to 9 and 0 to 1. There are like fair reasons. It's not like these digits come arbitrarily. There are fair reasons why the system is start and end like this, but we are not going to cover it like here. Okay. So this is enough, which is enough. So one of the systems is decimal and another system is binary. So what are we going to do with this? There is this thing that any number, any number in decimal form can be converted to binary form. Let's say 10. So 10 can be 10 is in base 10 can be represented as in binary format like 1010. Now, those of you who knows binary system, great. If you don't, I'll tell you why is 10 10 or 10 is 1010. So if you look at this number, it's 1010. So how we are going to calculate it? To the power 1, to the power 2, to the power 3, to the power 4. That means I'm going to replace these numbers here with 2's power with 1, 2, 4, and 8. Now you are going to multiply it. So I will change the pen. You are going to multiply it. So the multiplication will result in 8 into, okay, I should change the pen to something better. So it will be like 8 into 1 plus 4 into 0 plus 2 into 1 plus 1 into 0. That gives us 8 plus 2, that gives us 10. So this is how the system works. That's why 10 can be represented as 2 in like this in binary system. Now, now that we have seen that any number can be converted into binary format, we will see that what we can do with this format. Binary system is the most common system and is generally used by all the systems for computational purposes. But there are some really cool operations which we can do on these numbers, on these bits, on these binary numbers, which can actually result in very good results which we can use anywhere in our programs. So let's see them. So till now we have covered what are bits. Basically, we covered like this. Like we have covered the binary system till now. So in any number, like in 10, it is 1010. This one, this individual zeros, ones, and zeros are bits. And our goal is actually to work on these individual bits, not the whole number, but the bits. Okay. So we are going to see the next section that is about bit operations. We are going to see some really good operations here. So let's move on to the next one. That is bit operations. So I'm going to quickly list down the operations which you can apply on any bit. First is and, second is or, third is not, fourth is your XOR. Okay. Then you have mm, right shift, right shift. Then you have left shift. Okay. So yeah, for and you have this one is for the logical and this is for the bitwise and. Then you have bitwise or. Then you have bitwise not. It's like the tilt sign. This is called tilt sign. Then you have XOR, right shift, and then you have left shift. Like shifting the bits to the right and shifting the bits to the left. Okay. So we are going to see one by one about what are these operations. So firstly, we are going to cover the AND operation. I'm going to quickly cover them here only. AND operation. So assuming that you have two numbers, that's 101, and the number you have is 111. So what if you take AND of these? Since this is a bitwise operation, it's going to look at each bit sequence here. So the first collection is this, the second one is this, and the third one is this. So it's going to take AND of these two. So it's going to be one because if you have two inputs, that says input one, input two, and output. So in case of AND, the result is like this. For 0, 0, you have 0, for 0, 1, you have 0, 1, 0, you have 0, and 1, 1, you have 1. So, so when the both of the inputs are high, the result is 1. It's 0 and it's 1. So you can see that actually got the same number, which actually says that if you and if you and anything with such a number which is like all set to 1, you get the same number. Okay, you get the same number like here. So what is this number? Can you say? It's 1, 2, 4. This is 5. This is 1, 1, 1. This is 7. So 5 and 7 is actually 5 here. You can like really check out like few more stuff like this, and you will really get some really cool results. Now that we have seen this, now that we have seen the first example, let's move on to the next example. Let's move on to the next example. This is the first. Let's move on to the second example. Now, what we can do in this example? Let's say you have two numbers, 110, and you have another number that is 101. And if I add them with this number, what will the result? Let's see. This is 0, 1 is 0, 0, 1 is 0, 1 is 0. So we got a 0. Here we get a 1, it's a 0, it's a 0. Now you will say, okay, there's nothing useful here. But can you look at this section here? Okay. You'll say, okay, there's nothing special here. Both of them are same. Okay. I'll tell you another example. 0, 1, 0, 0, 1. Okay. And I got this number. Actually, if you see this number here and this number here, these are essentially same. Okay. These are essentially same because increasing zeros at the front will not result in any change in the number. Okay. Okay. So let me let us answer this question. So this is one one. This is one. This is zero. This is zero. You will say this is zero. Okay. So yeah, this is zero. This is zero. Zero 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 zero. Now can you see a pattern? All of these digits are zero, and only this is one. And this is the main property of AND. If you look at this number here, if you look at this number here, this is essentially 1, 2, 4. This is 6. And this number is here 5. And this is the property that if you if you add any number with 1, then n and 1 is equal to 1, 0, 1 if n is odd, 0 if n is even. Okay. So this is one of the properties which and supports that if it's 1, 0. See, so you can actually recheck these things here. I'm not going to extend it much. So let's see. for the or. Okay, so do we have any special property with or? So let's check. I will take this number here and I'll or it with 0, 0, 0, 0. Let's see what it is. So we are going to see that it's 0, it's 1, it's 0, and it's 1. So in case of or, in case of or, n and 0 will result into n. And here n and 1 is equal to n. Okay, okay. So let's look at to the next example. Let's say 0 and like 1, 1, 1, 1. So let's see, we are going to taking or, we'll take or, so it's 1, it's 1, it's 1, and it's 1. Okay. So irrespective of the number, n and, sorry, and or 1 is equal to 1. Ah, let's change this here. It's or, okay. Well, let me get some space here. Well, let me get some space here. Uh, n and 1 equal to n and 0 is equal to 0. Okay. So here you have another property. Okay. Here you have another property. This. So we covered some here. So if you take n or 1, you are always going to get a 1. So till now we are not having any special property with or. Hmm. If you it, look at it, what can you say? Hmm. What can you say? No, it's not n or 1. Sorry. It's not n or 1. It's actually n or share. Let me change it. So this is actually n or n or 2 to the power number of bits in n minus 1 is equal to is equal to 2 to the power number of bits in n minus 1. Okay. We are going to get the same thing, minus 1. Okay. And here also I'm going to change it. It's not 1. It's actually 2 to the power k minus 1 is equal to n. Okay. K minus 1, where k actually represents number of set bits. You will see like 1, 2, 3, 3 set bits. So it's like number of set bits. It's like number of bits in n. Okay. So what do we have covered till now? Hmm. Okay. Really good. Yeah. So let's move on to the next thing. There's not much in or and also nothing in not. Okay. In not also not inverts the bits in a number. Like if you have 101 and if you not it, then it will be 1010. Okay. If you not them, it's just there's nothing much to actually understand here. Now comes the main thing, that is XOR. For XOR, the thing which you should remember is if both of the inputs are different, then only the result is high, otherwise it's low. Okay. If both bits are different, then output is high, else low. Like if you have B1, B2, if you have B1, 1, 0, then output is 1. If it is 0, it's 1, then the output is 1. Otherwise, in case of 0 zeros and 1 ones, it's 0. Okay. So, how we can calculate for the XOR? Let's say I have two numbers, 1 0 1 0, like from the earlier example. We are going to take this number and we are going to XOR. This is the sign for XOR. So we are going to XOR these two numbers. So let's say these are two different. It's high, same zero, same zero, same zero. So in this case, we got 1. So what is this number? And this number is 10. We have seen earlier, this is 11. So XOR, this is 1. Okay. Hmm. Can we check for the same for the numbers? Let's say this is 1010. This is 1011. And I'm going, this is 11, and I'm going to take for the 12, 111100. This is 12. You can calculate yourself. This is 12. Okay. Okay. So this is 1, this is 1, this is 1, and this is 0. So what we got here? We got 7. Okay, great. So this is how we can calculate XOR of two numbers. Where it can be used. Let's say you are asked a question. You are given an array of numbers. Find the number which is not repeated. Other numbers are repeated twice. Example, if you are given an array like 1, 1, 2, 3, 3, 4, 4, 5, 5. So how you can do this question? For this question, you need to understand one of the things. That is XOR of the same number. Let's say earlier example. This is 10. And if I take XOR with 10 only, what will happen? The same 0, 0, 0, 0. So you get, what do you get? You get 0. Okay. And if I take XOR of 0 with any other number, that says 12, this is 0, 0, and this is 1, it's 1. So this gives me 12 again. So what we got from here is, okay, n XOR n is equal to 0, and 0 XOR n equals n. Okay. So with this property, what we can do is, if I take XOR of all the elements here, let's say 1 XOR 1, XOR 2, XOR 3, XOR 3, XOR 4, XOR 4, XOR 5, XOR 5. So what will happen is, as XOR is also associative and also commutative, what will happen is you can actually shift these numbers here and there. So you can take like this, you can take like this, this, and this. So same numbers, let's give you 0, XOR 2. Same numbers is give you 0, 0, and 0. Now you can see this is going to give, from this property, that 0 XOR n is going to give you 2 XOR 0 XOR 0 XOR 0, which can be again translated to, if you again do it, you will get 2, and bingo, you get the same number which is not repeated. Okay, bingo, you got the answer. So the solution is XOR all the numbers. This is the solution. Can you extend it? Can you extend this question? If the repetition is even times, then find the non-repeated number, non-repeated number. Then in that case, even if it is like 1, 1, 1, 1, this 2, 3, 3, 3, 3. In that case also you are going to take XOR of all numbers, because ultimately all those numbers will, all those operations will reduce to 0, and you are again going to get answer as 2. So this was for XOR. Okay, I quickly covered these things here. Let's move on to the next thing, that is bit shift. Okay, bitwise shift. I'm going to cover left shift and right shift. Left shift, right shift. Okay, and these are pretty interesting. Let's say you have 1010, and you have already seen that the uh, it's like you are going to shift the numbers to the left. So the left shift and this is right shift. So this is pretty interesting. It's just like that this is the number, and if you left shift it by 1, you are going to push a 0. It's like pushing a 0 in the stack. So the number will become a 0, 1, 0. And this is a number. Again, if you do, you are going to push a 0 here, and only the zeros are pushed. Okay, only the zeros are pushed. So a number is this, and if I left shift it by one, the number becomes this. So what is this now? By now you know it's 10. What is this? This is 1, 2, 3, 1, 2, 4, 8, 16. Wait, this is 16 plus 4, it's 20. Okay, you've seen that, okay, 10 becomes 20. And that's the property. In left shift, the number actually doubles. Number actually doubles. Why it's happened? Because you have actually added a bit here. So it's like here, it's like when the bits are shifted, 2 is getting multiplied to each of the bit. Like here, 1 is already same, only the factor which is multiplied with this is double. Like earlier, we are multiplying these, and now for the same bits, we are multiplying 16, 8, 4, 2. Yes. So for the same bits, the factor has doubled. The factor has doubled, and that's why the number is doubled. So left shift by 1. Okay, so how we can summarize it? How we can summarize it? How we can summarize it? If I left shift a number by 1, then n left shift 1 will be equals to that. So n number will double. Okay. So what do you think about right shift? So if it is 1010, then if I left shift it by 1, the number becomes 101. This is like you are dropping a bit from the end. The right shift is dropping a bit from end. So if you drop a bit from the end, what will it become? This is 10. This is 10. What is this? This is 5. So number actually halved here. And that's the property. That's the property. If I right shift, right shift, number, then n right shift 1 will be n by 2. And you can extend it. Like if I left shift by if I, then first time the number doubles, second time the number again doubles, and again doubles. So it will be n into 2 to the power I. But here also n I, so it will be n by 2 to the power I. Another thing, why we do it like this? You can always multiply and divide. I'll tell you. Bitwise shift operations are much faster than normal operations. Bitwise shift operations are very fast as compared to normal operations. Oh no. Bitwise operations are pretty fast as compared to normal operations. So we have got a lot of data here. We have seen a lot of things here. Sorry for the background noise. It's like some construction is going on here. Sorry for the background noise. So we have covered pretty fast about like bitwise operations, bit shift, left shift, exhaust, and all the properties we have seen here. And we have seen some pretty good manipulations also.